So hello guys, we have over here the first problem in a series of my favorite problems. We'll be having one of these problems each day and we'll be solving these with you together. So you can see we have our first problem over here. Over the first few weeks we'll be doing a lot of geometry problems, and this first week we're going to be working a lot with right triangles. So you can see we have a right triangle ABC, with the angle BAC being the right angle. So we know that AB is greater than or equal to AC, and that the line segment BD is equal to BA. So there's also something else quite weird, which is that DE divides the area of the triangle ABC into two equal areas, which are the triangle BED and the quadrilateral AEDC. So at first this might seem very peculiar, as we're trying to prove that two line segments are the same length and that we have an area comparison that is quite useless. However, we must remember that for any two triangles that have the same height and the same base, they have the same area. This applies when the two triangles also have a shared height or shared base. So we will try to change the shape in a way so that we can apply this principle of area to find out the lengths of line segments. So you can try to add a few lines to this shape to make it easier to solve. So assuming that some of you tried this already, we can translate one of these. So you can see the triangle ADC can be changed a little by translating DC onto a line that is parallel with AB, or they're the same line. So you choose a length that is equal to that of DC, then you connect this line with that was a problem. So then you connect this line that you extended to the original point D. So now, as you can see, we have another triangle, which we're going to call it here. We're going to call this triangle C mark, and this point will now be A mark, this point being D mark. As you can see, we've changed this triangle so it has the same area, since we've defined that C mark D mark will be equal to the original CD, and they have the shared height in A and D. So over here, we can see now it's way more obvious that because we have one large triangle that is divided into two separate triangles by the line DE or A mark E, so it should be way easier to prove what we're talking about right now. So you can think about how this works, because I'll put down what we did. So I'm writing, to further reinforce this proof, we can set a line segment D mark C mark, which is equal to the original segment CD, and since A mark D mark is the same line segment as the original AD, we can also say that the two triangles ACD and A mark C mark D mark are therefore congruent to each other. We can thereby say that the area of ACD is equal to the area of A mark, C mark, D mark. So with this in mind, we could reinforce what we need to do. So as we know that we want to find two triangles equal area, since we know that since the area of A mark BE is equal to the area of the newly constructed A mark EC mark, we can also say that the two segments BE and C mark E are equal to each other. Now it becomes a lot more straightforward because we know the equality between these. However, as you might remember, we're talking about right triangles here. We can form a right angle here too. As you see, remember that since BAC or the angle BAC or the angle BD mark C is equal to 90 degrees, and that this angle is constructed of these separate angles BD mark A mark and A mark D mark C, we can also prove that the newly constructed angle C mark A mark B is also equal to 90 degrees. As you can see in the picture above, in the diagram above, we have since BD mark or BA is equal to BA mark or BD, we have that the triangle BA mark D mark is an isosceles triangle, and that so that BA mark D mark, the angles BA mark D mark and BD mark A mark are thereby equal to each other. So now we have these two angles that are equal to each other. So we also have the angle, since we proved that the triangles A mark, C mark, D mark, and A mark, C, D mark are congruent to each other, the angles D mark, A mark, C mark, and A mark, D mark, C are also equal to each other. And because two things that are equal to each other added with two things that are equal to each other, produce an amount that is equal, we can thereby say that the angle BA mark C mark has the same measure as the angle BD mark C, which is 90 degrees. So what can we do with this equality? So, as you might know, for the bisector of the hypotenuse of any right triangle, the bisector is equal to the bisected segments of the hypotenuse. We can use this to prove that A mark E is equal to C mark E and is also equal to BE. As you might remember, we as you might remember, EA mark is also the same thing as ED, since we replaced these points. So we have proved the first part of this equation, which is that BE equals ED. To prove the second half of my equation, we can also use the fact that A mark E is equal to ED mark, which makes it exactly half of the segment BD mark, or AB. So now we have proved the second part of our equation, which is that BE is also equal to half of AB.